Class intervals. When there is a large mass of data, to make the presentation of data more meaningful, we condense them into convenient number of classes or groups, generally not exceeding 10 and not less than 5. In the above example, the data is condensed into 7 groups such as 20, that is 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80, and 80 to 90. Each of these groups is called a class interval. In the class intervals, 20 to 30, 30 to 40, 40 to 50, etc., the common variable 30 is counted in the second class interval 30 to 40 and not in the first interval 20 to 30. Is that clear? In the interval 20 to 30, 20 is called the lower class limit and 30 is called the upper class limit. The difference between the upper class limit and lower class limit is called the size or width of the class. In the above class intervals, the size of the class is equal to 30 minus 20, which is equal to 10. The average of upper and lower class limits of a class is called class mark or mid-value of the class. In the above class intervals, class mark of 20 to 30 is equal to 20 plus 30 by 2, that is 50 by 2, which gives us 25. Frequency distribution table. Now students, please observe this very carefully as it is very important. Now draw 3 columns. First column, you mark it as class interval. In the second column, mark it as tally marks. Third column is meant for frequency. Alright, so now observe the following table and you will get an idea. Now, if 2 new students who scored 30.5 marks and 40.5 marks are admitted in this class, then we cannot add them in the ones ending with 30 or 40, nor to the following ones. This is because there are gaps in between the upper and lower limits of 2 consecutive classes. So, we need to divide the intervals so that the upper and lower limits of consecutive intervals are the same. For this, add 0.5 to the lower limit and add 0.5 to the upper limit of a class. For example, the new class interval for 20 to 30 is 20.5 to 30.5.